Okay, guys, today we're going to talk about exponential functions and their graphs. As sad as this is to say, I can relate an exponential function to something that's happening right now in our lives. Coronavirus. Okay? An exponential function, the graph starts off slow and gets big in a hurry, I say. Same thing happened with corona. You know, you got like one person got corona, and then they gave it to someone else, and then they gave it to their family, and then they gave it, and then all of a sudden the graph looks like this. If you look at any graph that talks about the spreading of coronavirus, it's an exponential function. You guys have talked about exponential functions before. You've talked about it in Algebra 2. Talked about exponential growth and decay and stuff like that. The exponential function looks like this. You have a base and you have an exponent. If you notice, guys, an exponential function, where is the variable? Where is your x, I should say, because these all are variables. But where is the x? It's in the exponent. Okay, so an exponential function will have a base right here that's greater than 0. It's not going to be a negative number. A negative out in front will mean something else. We'll talk about it. But the exponent is your x value. That's where you'll be plugging in how you evaluate and stuff like that. So if I have 4 to the x power, 6 to the x power, 1/2 to the x power, those are all exponential functions. This is considered a growth, and this is considered a decay. Decay, and we'll talk about this in a second when we talk about all of the characteristics of graphs. But it'll be a whole number. Shouldn't say whole number. It'd be greater than 1. Your decay would be a number between 0 and 1. So let's talk for a second. I'm going to go through this very quickly. If you guys ever have a test or a quiz question where it says to evaluate, that just means figure out the answer. All right. You obviously have to use a calculator for this. So if you don't have one on your iPad or you don't have one on you right now, no big deal. But in order to evaluate this, you guys would say it's 0.5 to the x power. So I would plug in 1.2 for x, so 1.2. On your calculators, if you guys have one at home or you have one here, there's a button that's called a caret. Looks like that, looks like the top of an arrow. The caret button is how you raise something to a power. Bigger than, a lot of you know, there's x squared on the calculator. But the caret button is how you raise. Guys, if it says to round to 3 decimal places, I'm sorry, but we're in high school, we're in an honors math class. If you guys don't know how to round, we're not going through that. 3 decimal places means 3 decimal places. If you have something on WebAssign, it says to round to whatever, and you're getting the answer wrong, and you're telling me, I know it's right, check to make sure that you're rounding correctly or incorrectly. That could be the issue. Something else I want to bring to your attention, guys. You won't always be able to use calculators on everything, but calculators are only as smart as the user. And I don't mean anything negative by that. I'm just saying whatever you put in is what you're going to get out. If you guys have a calculator and right now you write or type in -2 squared, your calculator is going to tell you the answer is -4. Is -2 squared -4?
No.
No. But what happens is your calculator does order of operations for you. So it does the exponent first, it evaluates the exponent, and then it times it by -1. So what you need to do in your calculator, especially if you have negative numbers, you guys need to give them a little hug. You need to put them in parentheses. So you're telling the calculator here to take take -2 and multiply it by itself, rather than take 2, multiply it by itself, and multiply by -1 at the end, okay? So when I'm putting in this one, number 2, you should have something like this. Put everything that's negative, just put it in parentheses. That's a little like up arrow, like the exponent thing that I told you about. Just use parentheses. It's important. Everybody got it, all right? Okay, let's talk about the characteristics of an exponential function. Exponential function just means I have a base and then I have an exponent that is a variable. Your domain of your exponential functions is all real numbers. Similar to when we had our parabolas, our quadratics, all real numbers. Please don't get that wrong. The range, if I'm talking about my parent function, which is just like my blue line here, or my blue curve, if I talk about the range, It's 0 to infinity. Does it include 0? The way that these notes are written, does your range include 0? Yes or no? People at home, talk to me.
No.
Why? Why? Why are we saying no?
Oh, I didn't see that second one. Yeah, so it
I'm not
wasn't-
saying, I'm not saying you're wrong. I'm not saying you're wrong. But why are you saying, by looking at this, why are you telling me no, it does not include 0?
Because there's a parenthesis,
Because there's a parentheses. Good.
not a bracket.
Correct. In our exponential functions, your range is always going to have a parenthesis because your range is going to be dependent upon the horizontal asymptote. What do we know about a graph and an asymptote? Gets really, really close, but what? Doesn't touch it. Good. So your asymptote is going to be, and we'll talk about this in a second, whatever you add or subtract to the end of the function, whatever your vertical shift is. Right now, I'm not adding or subtracting anything, so that's why it's 0. But your range is always going to be from the horizontal asymptote to infinity for what we're talking about here. You will have a y-intercept. For the parent function, it's going to be at 0, 1. All right, if you look here, look at the difference between the blue and the red line. What's the difference between the blue and the red? I say line, it's a curve. What's the difference?
The red is negative.
Okay, we could say that it's negative. Not necessarily. I know what you're talking about, Isabella, because it's going down, correct?
Yeah.
This would be called a decay because it's going down. We'll talk in a second about what negatives do. Sometimes we'll talk in a second. This is a decay. If you notice when we talk about decays, that's when your base is between 0 and 1. 1/2, 1/4, 1/3, something like that, a fraction. We have a growth when it's a number greater than 1. So 4 to the x, 5 to the x, 7 to the x, something like that. The bigger the number of the bigger the base, the faster, the steeper that your graph will rise. All right? Again, horizontal asymptote, that's going to be dependent upon your range. Range dependent upon horizontal asymptote. Go together. All right, so let's look at these two. Let's talk about these two graphs. What do you notice is similar or the same in each of A and B?
They have the same base.
They have the same base. Good. What do you notice is different?
They have a negative.
There's a negative in the exponent. So let's just do this quickly. I'm not going to graph every single thing here, but let's do this quickly. Let's make an XY chart. I like to tell you guys to use 2 negatives, 2 positives, and 0 when possible. So we're going to do that now. If you have a calculator, you can use it. If you have a brain, you can just use that. If I plug in a -2 here, what is 3 to the -2 power? Anybody?
9i.
No, it's not imaginary. It's not imaginary.
Oh, negative, not technically.
It's not negative. Think about it. If I have 3 to the -2, that's the same as saying 1 over 3 squared, right? Isabel, I heard 0.111111. Well, if I write it as a fraction, it's going to be 1/9. If I have 3 to the -1, it's 1/3. If I have 3 to the 0 power, what's 3 to the 0 power?
1,
Good. 3 to the first power?
3,
3 to the second power?
9.
So if I was going to plot these points in graph, again, so I have -2 and 1/9. Just get as close as you can. -1 and 1/3. 0, 1. 1, 3. And 2, 1, 2, 3, 4, 5, 6, 7, 8, 9. 9, like there. Okay, when you draw your graph, it's a nice smooth curve. You don't connect the dots like you're in 3rd grade. It's a nice smooth curve. We get close to the asymptote, but we don't touch it. We don't cross that x-axis. And that's what our graph looks like. So now, conversely, if I come over here, same thing. I'm going to do the same values, -2, -1, 0, 1, and 2. If I have 3 to the negative -2 power, that's the same as 3 squared, right? Yes or no?
Yeah.
Okay, so I have
Yes.
9. This is 3, 1, 1/3, 1/9. So my graph is going to look like this. 1, 2, 6, 7, 8, 9. 1, 3. Whoops. Okay, looking at these two. What does it look like happened? They flipped. I agree with that. Where did they flip? Over the x-axis or the y-axis? The y-axis. How do you think I could have told that just by looking at the function without having to graph it? How could I have told you, oh, it's going to reflect over the y-axis?
Because like one is negative and the other one is
Where is the negative though? It's in the exponent. It's on the x. If there's a negative in the exponent on your x, that's going to be a reflection over the y-axis. If the negative was out in front, according to all the functions that we've done before in Algebra 2 and knowing where stuff shifts left, right, up, and down, what does a negative out in front of a function do?
It would reflect over the x.
It reflects over the x. Good. So you guys should be able to have a mental picture of what these graphs look like before you even plot points. Some of you are going to get stuck on this part. When you put it in the calculator, you don't know where the point goes. Obviously, you're going to have to guesstimate. I don't know exactly where 1/3 is on this tiny little grid, but you just get it close. It's been between 0 and 1. It's closer to 0. But you should be able to look at a function, and that's probably how the quiz will be. You should be able to look at a function and tell me where it shifts, up, down, left, right, shrink, stretch, those sorts of things. You can also tell me domain and range just by looking. So let's look at the next one. Let's compare. Okay, how are these two similar and or different?
One is a decay, one is a growth.
One is a decay, one is a growth. Do you notice here, Ms. Carver, if I go back, does it mess up the video? Yeah. Okay. On the first one, guys, that I showed you, the bases were the same, right? 3 to the x and 3 to the negative x. The bases were the same. Our transformation, our reflection, however you want to say it, happened in the exponent. In this case, 1/4 and 4 are what of each other? They're reciprocals. One is a decay, like Isabella just told us. The other one is a growth. So in this case, we would just make an XY chart. -2, -1, 0, 1, and 2. If I have 1/4 to the x power, and I plug this in, right? If I say 1/4 to the -2, does anybody know what that is? Can anybody tell me? It is 16, good. So 1/4 to the -1, that's going to be 4. 1/4 to the 0 power is 1. Then I have 1/4. Then I have 1/16, right? So when I graph this, I'm going to start with 4 just because the graph is weird. At -1, 4. Then I have 0, 1. 1, 1/4. And then 1/16. So it's like this, a decay. We said at the beginning it was a decay because it's a fraction. It was less than 1, so I know it's going to be going downwards. So now I'm going to do the exact same thing, but I'm going to use 4 to the x. Well, guys, if it's reciprocal of each other, all that's going to happen is the numbers are going to switch. So 4 to the -2 is 1/16. This is 1/4. This is 1. This is 4. This is 16. So my graph is going to look like this. Well, let's go this way. Again, we should get close to the x-axis but not touch it. I didn't mean to there. But the reason why this is a reflection and then this is a growth and a decay is because here the bases are the same. Here they're reciprocals of each other. Just showing you graphically how things can look a little different.
Wait, why can't you touch the other side?
That's the asymptote. It gets real close to it, but doesn't touch. What we're going to talk about here, all right, if I gave you guys this, and I said, what's all the transformations that are happening here? What would you guys tell me? Where is this parabola going to move? Nobody knows?
Go down
Okay, down 1. This is my vertical shift, so it's down 1.
the left 4.
It's going to go left 4. Good, Pablo. And then what does this 1/3 out in front mean? Is it going to shrink or is it going to stretch? Vertical shrink or vertical stretch? To shrink. The exact same rules apply, guys, to exponential functions. Like I said, you should be able to look at a function, exponential, and tell me where it moves and what the domain and range is. Because if I have a vertical shift up or down, you have your exponential function. If I add something to it, it moves up. If I subtract something from it, it moves down. This is also your horizontal asymptote. We'll talk about that a little more. But if I'm going to move my exponential function left and right, notice where the left and right is. Is it behind the function or is it involved with the x? Is it involved with the x or is it adding or subtracting at the very end?
It's adding or subtracting.
At the very end, or is it right here with the x?
Oh, at that one. It's with you.
It's with the x, just like it is up here. Our left and right goes with the x, whatever it's kind of stuck with. Same thing with exponentials. For our reflections, if I have a negative out in front, that's going to reflect over the x-axis. If I have a negative up here with the x, it's going to reflect over the y-axis. Same thing with our vertical and horizontal stretches and shrinks. If I have a number in front that's greater than 1, it's a vertical stretch. That's less than 1, it's a vertical shrink. If I have my stretch or shrink that's in with the x, that's going to be my horizontal. It always has something to do with the horizontal axis. So you should be able to, after today, you should be able to look at this without even graphing, and you should be able to tell me what the domain and range is of each function and where it moves. So let's look at this first one. Exponential function, yes? Yes or no? Yes, okay, so I always tell my kids to circle the function itself. What is being added or subtracted? Nothing. So my domain, since it's exponential, what's my domain? Negative infinity to positive infinity. My range is based on my vertical shift. If I'm adding nothing to it, then my asymptote, my horizontal asymptote, is where? At 0. So your range would be from 0 to infinity. It does not include 0 because your asymptote does not touch it. In this case here, what's my domain? What's the domain of all your exponentials, guys? Negative infinity to positive infinity. What's my range here? Perfect. 3 to positive infinity. Good. Because all I did was take my exponential function, my smooth curve, and I moved it up 3 units. So it's going to get real close to 3, but not what? Not touch it. If I asked you to find what the y-intercept was, how would you find what the y-intercept is? How do we find when we factor, when we have a quadratic? What did you guys do to find the y-intercept? You plug 0 in for x. So if I plug 0 right here, what's 4 to the 0 power?
0.
No.
Oh, 1, 1, 1.
1. And 1 plus 3 is?
4.
4. So you guys could tell me that the y-intercept here is at 0, 4. There's a lot you can tell just by looking and knowing what you're looking for. So tonight, when you guys are doing your WebAssign, you should, yes, you'll be able to pick your graphs just based upon what I'm telling you. But for tonight's homework, I want you to actually make an XY chart and graph the exponentials then pick A, B, C, or D. If all you do is just pick the multiple choice and tell me, oh, I did it in my head, I'm not going to give you guys credit. I need tonight for you guys to actually graph them. Sound good?
If it's to show work for that, how would you do it? Would you just
Like actually graph it.
how you do it?
There's going to be some questions that you're not going to be able to show work for that they're like what I'm saying to you right now. What is the difference between these two? Look at it and tell me the difference.
Exactly.
Where does g of x move?
To the right.
Guys at home, where does g of x move? Good job, Pablo.
To the right.
Yep. This is a horizontal, so you would go right 2. I think the questions are asking like, I think it says what is the difference between one and the other, and it'll say g of x was shifted horizontally 2 spaces to the right, something like that. But you guys can tell me a lot about this graph. Tell me right now what the domain is. Everybody should be saying, what's, yep, all reals, negative infinity to positive infinity. What's my range? Good. What's the range, people at home?
Isn't that still 4?
Not 4. What are we adding or subtracting right here? Yep, 0 to infinity. All it did was move left or right. It didn't move up or down. How would I find the y-intercept? Plug in 0, right? So I plug in 0 here, and it's not going to cross. Where is it going to cross? If I said, what's the y-intercept? You guys would tell me the y-intercept is at, what's 4 to the negative 2 power? 1 over 16. Good. Very good. Good, good, good. So don't get stuck on the graphing part. I want you guys to be able to obviously make a table of values. I want you guys to be able to recognize growths and decays and all that stuff. But you should be able to look at a function, just the function written out, and tell me which way it moves, if there's a reflection, which way it reflected, that sort of stuff. You should be able to identify all of that. And we'll work on it. Yes. One-to-one property. For a one-to-one property, a greater than 0 and a is not 1, then a to the x and a to the y, if and only if x equals y. Does anybody know what that means? Okay, I'll show you in 1 second. Super easy. This right here is very important. Anything raised to the power of 0 is 1. If I give you a question, like I'm going to show you in a second on the test or a quiz, I guarantee you 1/3 of you will get this wrong. It's not a hard concept. Anything raised to the 0 power is 1. Remember that. Now, we're going to look at these problems. These 3, and then we're done. It says solve using the one-to-one property. If they tell you to solve using the one-to-one property, then you can always solve based upon the way I'm showing you how to do this. The first thing I want you to do is I want you to get bases to be the same. And I'll show you what I mean in a second. But the first thing you need to do is get the bases to be the same. Once they are the same, you're going to cross out the bases. And then you're going to set exponents equal to each other. Now, if I tell you to solve using the one-to-one property, then you can. Don't tell me that you can or it doesn't work or anything like that. You can do it. Another thing I want you guys to keep in mind, and I want you to remember, fraction equals a negative exponent. Just keep that in mind. So if I look at letter A, okay, letter A says 3 to the x minus 2 equals 9. Well, the first rule that we're trying to follow, the first thing we want to accomplish is to get the bases to be the same. Can I break down 3? Is there another number times itself that'll give me 3? No. So I'm just going to rewrite 3 to the x minus 2. Now, is there a way that I can break down 9 so it has a base of 3?
Yes.
What would that be?
3 times 3.
So it would be 3 squared. Agreed?
Right.
All right. So now that the bases are the same, what did I tell you to do once the bases are the same? Cross them out. And then what do you do? Set the exponents equal to each other. So if I solve this, x minus 2 equals 2. I'm going to add 2 to both sides. Agreed? X equals 4. So check that. Plug 4 in for x. Whenever you get x equals, you can always plug it back in and check. So what's 4 minus 2?
2.
2. What's 3 to the second power? 9, which is what we want. So,
So our answer would be like 4, right? That's what
yep, x equals 4. Yep. So come over here to this one. Okay, this one's a little different. Whenever I see a fraction, I always rewrite it. I rewrite my fraction because sometimes this can be confusing. I'm not asking you to divide 16. I'm asking you to write each side of the equal sign so that they have the same basis. So I can rewrite 1/2. Do you guys agree? If I bring this up here, because this is 2 to the first power, right? If I bring the 2 into the numerator, what does that 1 become? The exponent. What does the exponent become? Negative. So I can rewrite this as 2 to the negative 1x power. Agreed? Now, some of you are going to say, I could just look at this and say it's negative 4. Okay, fine. That's fantastic. But if I'm telling you to solve using the one-to-one property, I need to see this solving process. I need to see that you get the bases to be the same, cross them out, set exponents equal to each other. Is there a way that I can write 16 to where it has a base of 2? Anybody?
Yes.
What would it be? 2 to the what? 2 to the fourth power. Good. 2 to the fourth power. That's the same thing as 16. So now that my bases are the same, ladies and gents, what do I do? Cross them off.
Cross them out.
Now I set my exponents equal to each other. Negative 1x equals 4. What do I do to both sides? Divide by negative 1.
By negative.
So x equals 4. Yes.
Wait, negative 4?
Yeah.
Okay.
Yeah.
I'm confused how you have to turn the fraction into 2.
Okay. So if I have, any time you have a fraction, like if I had 1/3, this is 3 to the first power, right? If I bring this up to the numerator, 1/3 is the same as saying 3 to the negative first power. So all I did was just take the 2 and put it into the numerator. So it became 2 to the negative 1, and I just put it with the x. All right, let's look at this last one. I really try to make your brains explode on the last example. What's my answer here? How do I change 6 into the base of 1? Or how do I change 1 into a base of 6?
6 to the 0 power is 1.
Atta girl. I guarantee you, if we put that on a test or a quiz, there will be at least a third of you that get that wrong. I have seen people absolutely invent math. Like 30 steps to get this. Guys, this is not rocket science. Anything raised to the 0 power is what? 1. So if you have an exponential function, anything, if I had 1/3 to the x power equals 1, anything that's raised to the 0 power is 1. That is not a trick question. That is absolutely, that's a very, very, very important thing for you guys to remember. That's why it's on here.